zeros. And we've gone through Boyles and Charles. Which variable have we not held constant yet? Volume. So we will be manipulating pressure and temperature at a constant number of moles and volume. Okay, there's a typo here. They should say Gay-Lussac. So Gay-Lussac's law is the relationship between pressure and volume at a constant number of moles and volume. Same thing. We start off with the combined gas law and we break it down. P1 V1 T2 is equal to P2 V2 T1. Okay, because V volume is constant, V1 is equal to V2. Therefore, we can sub that in. P1 V1 T2 is equal to P2 V1 T1. Volumes cancel each other out. And then we get Gay-Lussac's law, which is P1 T2 is equal to P2 T1. Okay, so right here, P1 T2 is equal to P2 T1. That is one way to write this formula. Or you can write P1 over T1 is equal to P2 over T2. Okay, either way is correct. Again, pick one and stick with it. Okay, let's take a look at an example. Determine the pressure change when a constant volume of gas at 1 atm is heated from 20 degrees Celsius to 30 degrees. Okay, let's set up our variables first. We have P1, P1, P2, V2. So, P1 is 1 atmosphere. T1, 20 degrees Celsius, plus 273. Let's convert them right away. We know that we cannot use degrees Celsius, so this will give me 293.15 Kelvin. P2 is what we are looking for. Oh, I wrote V2 for some reason. T2. T2 is 30 degrees plus 273.15 gives me 303.15 Kelvin. Okay, from here we will use our Gay-Lussac law. P1 T2 is equal to P2 T1. So we divide by P2 on both sides. Wait. P1 T2 is equal to P2 T1. This is what we want to isolate for, so we divide by T1 on both sides. P2 is equal to P1 T2 over T1. Okay, from here, let's do some subbing in. P1 is 1 atmosphere. T2 is 303.15 Kelvin. And T1 is 239.15 Kelvin. Kelvin cancels out. Atmospheres stay. There is a question asked. The question was, do we need to convert atmospheres into kilopascal? No. As long as your pressure, whatever you put in, is the units you will get out. So the Kelvin will cancel and your units will be in atmospheres, which is a measure of pressure, which is okay. Okay? So your answer for this guy will be okay, sorry. You get an answer of 103 atmospheres. Okay, now let's look at this. What happened to temperature? Increase or decrease? Temperature increased. What happened to pressure? It increased as well. So the relationship is proportional. I'm the only one who raised his hand. So if temperature increases, what will happen to pressure? It will also increase. Okay, let's go through these diagrams real quick. If pressure increases, or sorry, let's say if temperature increases, therefore pressure will increase. Okay? So let's say we have this container of gas. It's the same size as container. And there's our 4 moles of gas flowing around. And the temperature is pretty low right now. So we'll say low temp. Because it has low temp, these molecules are moving very slowly. Very slowly. Then what happens is we increase the temperature. So let's say we are now at a high temp. The container shape doesn't change. It's the same volume. Now you have these 4 molecules that are traveling much faster. Because they're traveling much faster, they're going to be colliding with each other and the walls of the container at a higher speed. The more collisions they have, and the harder those collisions will be, pressure will increase. Okay, so that's why pressure increases. So this is what happens in a pressure cooker. Have any of you guys ever used a pressure cooker? What happens is, does your pressure cooker grow in size?
Yes,
All the time. Just casually. It grows all the time. No, for real. Does it grow? No. If your pressure cooker grows, something's wrong. Okay, so what happens in a pressure cooker is you put the lid on, you contain that volume of gas, okay? Once the pressure builds up, you have to release some of that pressure. Otherwise it'll explode. So if the pressure gets too high, that's why you have the whistle. Here we go. So pressure and temperature are proportional at constant V and N, which is moles, okay? This relationship is directly proportional, therefore P is directly proportional to T. Again, that silly fish thing is not really a silly fish thing, it is the proportional symbol. Means proportional. It's spelled correctly, okay? It's spelled correctly. Therefore, let's say we have pressure and temperature. If pressure decreases, what happens to temperature? Decreases. Let's say if I have temperature now as my manipulated variable and my pressure as my responding, if temperature increases, what happens to my pressure? Increases. Okay, we'll do one more situation. Let's say we have pressure and temperature. I increase my pressure. What will happen to my temperature? Increase. Should we do the last one? Why not? We'll make a tiny one here. We have temperature and pressure. Temperature decreases. What happens to pressure? Decrease. Okay, a gas for the container. Initial pressure at 47 millimeters of mercury and 207 Kelvin. What will the pressure be when the container warms up to room temperature at 25 degrees Celsius? Okay, so P1, T1. That was not a T1. T1, P2, T2. P1 is 47 millimeters of mercury. T1 is 207 Kelvin. P2 is our unknown. T2 is 25 degrees Celsius. We are not allowed to use Celsius, so we add 273.15, which gives me a temperature of 298.15 Kelvin. Okay, once I isolate for the formula, P2 is equal to P1 T2 over T1. Plug those numbers in. P1 is 47 millimeters of mercury multiplied by 207, no, not 207, by T2, which is 298.15 Kelvin, divided by 207 Kelvin. Kelvin cancels out with each other, and we are left with millimeters of mercury. This is fine because it is a way to measure pressure. Once we plug that in, we should get an answer 68 millimeters of mercury. Does our answer make sense? Yes, it does. Okay, this one is for you to try on your own. A gas thermometer measures the temperature and pressure of a gas inside a fixed volume container. The thermometer reads a pressure of 248 kilopascals at 0 degrees Celsius. The pressure increases to a thermometer of 345 kilopascals. That's some weird wording. Okay, will the temperature increase or decrease? Increase. Okay, take a moment and do the math. Okay. I thought it was 2:05 today. No, it's not.